As you all know, Hive 13 has been rolled out. It's very fast. You could look at the benchmark numbers that we released sometime back in the Hadoop Summit and at the previous hub. But there's also something new with the Hive 13, which is its new security and authorization model. To talk about that, I have two speakers. I have Tejas, who is a software engineer at the Hortonworks, and I have Chris, who leads the development of Hive and Edgecat at Yahoo. So learn more about the security model at the Hive 13. Please welcome Tejas and Chris.
So, what are we going to talk about? I'll start by introducing some key security concepts, just to make sure that we're on the same page. And then I'll walk over some common use cases with Hive, and then go through the authorization solutions and discuss how those authorization solutions fit these use cases. And Chris will then talk about more concrete use cases at Yahoo and experiences at Yahoo with authorization. So the key security concepts. One is authentication and other is authorization. So let's take the example of entering a country. Let's say one with secure borders. So the first step for entering is allowing entry is verifying who you are. So you would do some biometric check your photograph and all that. And that is authentication. And the next step is checking if you have permission to enter the country, maybe check your passport, nationality, or the visa. And that step is authorization. Authentication in Hadoop is commonly done using Kerberos, and there are some additional options that Hive 2 provides for authentication. But overall, authentication is well documented and well understood. So in this talk, I'll be focusing on authorization. Before we dig deeper, let's ask the question, what is Apache Hive? So, like the story of the elephant and the 5 blind men, it will depend on who you ask. One guy may say that an elephant is like a rope, and another guy may say that elephant is soft and bushy. So let's replace elephant with Hive and the blind men with Hive users. So if you ask pig or MapReduce what Hive is, their view of the world, or their Hive view, is that Hive is a table-oriented storage layer. So when pig uses Hive through hcatalog, what it gets is the ability to a pig user gets an ability to just specify the table name without having to specify the data location, schema, and other statistics and other metadata. But if you ask other users like a BI tool or a business analyst, what they would say is that Hive is a SQL database, it's a SQL query engine. So these are the two primary use cases that I'm going to discuss. Let's dig a little deeper into the first use case of Hive as a table storage. So when Hive is used as a table storage by pig, MapReduce, or let's say an MBP database, they typically use this hcatalog library in Hive. And when they access Hive as a table, there are two components that are relevant here. One provides data, and that is HDFS, and the other component provides metadata, and which is the Hive metastore. So let's talk about how authorization is done for these two components. So the first component that we saw is data, and how is data authorized? So for a given table in Hive, you have some location where that data is stored on HDFS or any other file system. And HDFS supports traditional POSIX style permissions, so you can set permissions on that directory to restrict. who can access that. And now with Hadoop 2.4, you have even more flexibility in controlling permissions using access control lists. And with projects like Apache Argus, you have way more flexibility and way more usability features. So that was about data. So how do you authorize the second component, metadata? So let's say you have this table metadata and you want to control who has access permissions to read this table metadata or update the table metadata. So you have already taken time and set up the permissions right on for the file system. You have been worrying about that. And now here comes one more thing that you need to worry about. That's two worries. Two worries is too many worries. So what you use storage-based authorization. And the way it works is it relies on the permissions that you have already set up on the file system. You don't have to set up like another source of truth for permissions on metadata. So if for permissions on a table metadata, what it checks is if you have read or write access to the corresponding table directory on the file system. So if you have write access on the file system, you have write access on the metadata for the same entity. And how do you use it? So you have to change configuration on the Hive metastore to enable storage-based authorization. And you also need to take some other steps like ensuring that the backend database for the metastore can't be accessed directly. It should be only accessible through the metastore. Now, so that was the first use case with Hive as a table storage layer. And the other common use case is Hive as a SQL query engine. And one of the most common tools that people use for running SQL queries in Hive is Hive command line. But if you look closely at Hive command line, it's not actually any different from pig or MapReduce job. The components that are relevant here are the same. So you have a Hive query. When you given a Hive query, it looks at the metadata, figures out the query plan, and then processes the data by reading the data from the file system and then writing back. So the same storage-based authorization is very much applicable for the Hive command line as well. And the second common way you run SQL queries using Hive is using an ODBC or JDBC application or a tool. And the way, in this case, you have one additional component which is Hive Server 2. That's what your ODBC or JDBC driver talks to. And what Hive Server 2 does is not very different from what Hive command line does. The same query compilation execution that happens in Hive command line now happens in Hive Server 2. So this use case is also the same. The same components are relevant here, the metadata server and the data server. And so the same storage-based authorization is relevant here. And to be able to use storage-based authorization here, you need to ensure that in Hive Server 2, you have configured the queries to run as the end user. This is the default configuration, but and the config flag is this enable.do as flag. So we discussed how storage-based authorization can be used in all these use cases. So to summarize, what's great about storage-based authorization? It's simple. You just need to manage the permissions on the file system, which you anyway have to do, and then it will use that information to protect your metadata. And with the access control list feature in Hadoop, now you have even more flexibility in the way you can manage the permissions on the file system. So But what's missing in storage space authorization? So in case of storage space authorization, the authorization is checked based on permissions that you have at the file system. And the file system, the lowest granularity that you have for permissions is a directory and file. But what if you need to authorize access based on either columns or rows? That is not possible with storage space authorization because the permissions are not that granular. So, but some organizations require such finer grained access control. Before we discuss solutions for that, let's look at what are the prerequisites for fine grained access control. So, when you access data, you need to be able to access just the columns and rows that you need without requesting for the entire data, and which is what is lacking in file system. So if you give somebody access to the whole file, then you can't have fine-grained access control. So does Hive Server 2 change the picture here? So Hive Server 2 acts as a data server for an ODBC or JDBC application. When somebody is running a query through ODBC or JDBC, they don't read directly from HDFS. The data is actually coming through Hive Server 2. So you have this one additional component which also understands the concept of rows and columns, because SQL is the API here, and in your SQL query you can specify the rows and columns you need. So that's where SQL standard authorization comes in. So SQL standard authorization brings about fine-grained access control through Hive Server 2. And you get to manage the permissions using the familiar grant and revoke SQL statements. And this has been designed based on SQL standards so that people who are familiar with the access control or any other database can come and easily start managing access control here. And this is how, at a high level, the authorization policy in SQL standard authorization looks like. There are a lot of details which is well documented in the Hive SQL standard authorization wiki page. So what it comes to, the access control policy basically comes down to managing permissions on objects, privileges on objects for users. And the privileges can be privileges like select, insert, delete, and update. Objects are objects like table or a view or a URI. And the users that you map into can be a single user or a group of users. It also provides features for being able to delegate management of permissions. You can delegate somebody, give somebody permissions to grant options so that they can grant permissions to other users. And similarly, you can have certain people managing who gets in and who gets removed from a role. And there's also provision for having a sort of a super user kind of role for a person who is who has a role of a DBA in your organization. And how does this let you have fine-grained access control? And that is through views. So you can define a view and restrict the columns that are available through the view using a select statement. And you can also restrict the rows that are available in the view through your where clause in the view statement. And you give access only to the view without granting access to the underlying table, so that the access to that user is then restricted only to those columns and those rows. Hive also supports a lot of non-SQL features, and to be able to enforce fine-grained access control, we have to restrict access to some of those features. So DFS command is a classic example. Like as I discussed, if you give access to the entire file, fine-grained access control does not make any sense. So DFS commands are disabled. Then the other set of commands that are disabled are commands that let users inject malicious code. So you are not, it restricts the ability to add user-defined functions or use your own code in other places like transform clause. But UDFs, user-defined functions, are an extremely useful feature. So along with the SQL standard authorization work, what we did is add this concept of permanent UDFs. So an administrator of the cluster can add permanent UDFs that they trust and they consider safe. Now, how does a query processing work with SQL standard based authorization? So, for the query to be able to process data, you need access on the file system. And you have already again been managing the permissions using grant and revoke statement, and you don't want to do that work again managing permissions on the file system. So to make things simpler, the recommended setup is just grant the Hive server user permissions on the warehouse directories and subdirectories, and then you just need to manage permissions and use grant and revoke, and also make sure that the query actually runs as the Hive server 2 user. So the flag that I discussed earlier for Hive server 2 to work with storage-based authorization, that has to be turned the other way so that the queries all run as a Hive user. Now, it's not possible. Yeah, go ahead.
So when you said about the DFS commands not being disabled, did you mean like even things like browsing is disabled for users, or are there specific commands that you have?
So in Hive, the way Hive lets you write a SQL query, you can also write a like DFS minus ls command.
Yeah.
So running that DFS ls command itself is disabled. So the entire set of DFS commands are disabled. Only if you are an admin user, you'll be able to run a DFS command.
Okay, so through Hive, but
Through Hive,
what
yes.
about the regular CLI? Would that also get disabled, or only through the Hive?
This is
Only through Hive server 2?
yeah. So SQL standard authorization is only enabled on Hive server 2 because fine-grained access control using Hive CLI is not secure because you are anyway giving them access to the whole file. So this setting will affect only Hive server 2 behavior. So with regard to security, one thing that I have come to learn is that you get to see all sort of requirements. Each company has some sort of requirement, and it's very hard to meet all those requirements. So what do? You make it, let them write their own authorization. So as part of the SQL standard authorization work, what we did is we created a very extensible API for authorization. So if you have very specific needs for authorization, you can use this API to have your custom authorization implementation. And Apache Argus, which is a new incubating project in Apache, is the first user of this interface. So Selva will be talking, Bosco will be talking about Argus in more detail in the next talk. And there is also the Hive default authorization. So if you have been using Hive for a long time, you're probably familiar with this. This is the authorization that gets enabled if you just turn on the authorization flag. But this, for backward compatible reason, it remains the same default authorization mode. But this authorization mode is incomplete and hence unsecure. For example, anybody can run a grant statement. There's no restriction on who can run a grant statement and so on. And It also supports the grant invoke at the Hive CLI level, but this model, as I discussed, like the fine-grained kind of model on Hive CLI is like an unsecure model. So to conclude, so we discussed different use cases and different solutions, but often you have all those multiple use cases in the same organization. So what do? So depending on the use case, you can actually enable both and address both use cases. You can have storage-based authorization enabled in the Metastore to support users like Pig and Hive CLI and MapReduce users, and that will give them authorization on the Metastore. And if you have additional requirements that need fine-grained access control, then you can go ahead and enable one of the solutions for fine-grained access control at the Hive Server 2 level, and then have those users go through only Hive Server 2. And now I'll pass on to Chris to talk about Yahoo use cases.
Hi, my name is Chris and I work here at Yahoo. The next couple of slides I'll try to get through in about 5 minutes or so to try to keep on schedule. But they go over particular use cases that we have at Yahoo, and hopefully it will give you an idea of better? Better? Okay. So hopefully it will give you an idea of where some of the things that Yahoo has done in this area and some of the areas that we want to expand it into using the SQL-based authorization model. So there are two main use cases that I would like to cover in these few slides. The first one is the column and row level access controls, which they just concluded his discussion with. And the second one is how can we try to fill that gap of being able to provide some sort of limited amount of authorization support for the Hive CLI. So hopefully a lot of this content is familiar to you from what Tejas just said, and that reinforces those ideas. And the areas where we're a little bit different, maybe that emphasizes the space or the peculiarities of what Yahoo is doing. So again, to emphasize what Tejas was saying, for the column and row level based access controls, how we would implement that is based on the Hive 13 SQL standards based Hive authorization patch that was added. And this is managed by the Metastore. It's implemented within the Hive Server 2 engine, and it uses views to provide a fine-grained access control to any particular table that you wanted to grant limited access to. The second use case here is how can we provide some amount of authorization to the Hive CLI. And what we've played around with is an HCAT server-side implementation where we augment the functionality that is already available through the storage-based authorization provider, and we chain that with another Hive Metastore authorization provider plugin to provide some additional authorization there. So let's look at the players that we have here. In broad terms, we have basically two categories of actors here. One is the producer and the other is the consumer. And if you really want to get into it, you can consider certain types of consumers as being producers for other consumers downstream. So at Yahoo, generally the producers are running ETL jobs that are loading data from one system into another. These jobs are primarily implemented as pig jobs with some MapReduce jobs as well. The groups who are running these jobs are responsible for the data. They're owners of the data, which means that they need to have read and write permissions on the HDFS directories and files. By comparison to that, we have the consumers, and of course they have to be able to read the data, so they're either consuming all or some subset of the data that has been produced or that is being made available by the producers. So of course that means they have to have read-only file permission access. So let's look at the individual challenges that we have associated with each one of these players. So for the producers, we have certain SLAs, latency SLAs, on moving the data from one system and making it available to downstream users in another system. And oftentimes we're dealing with a very large volume of data at that. So the teams that are running these pipelines to load the data onto the HDFS are responsible for also managing this data. What that means is they would be responsible for reloading or regenerating data if there happen to be any sort of errors, or if something happened to be required where data had to be rerun. They might have to be responsible for producing roll-ups or aggregates on data on, let's say, a daily or a weekly or a monthly basis. And they may also be responsible for archiving or deprecating old data. And they would also be the gatekeepers for who would be allowed to access this data. So if myself as a consumer, if I wanted to access data that was being produced by Group A, I would have to ask them for permission to access their data, and then they would grant me that. Likely what that would translate into is adding me to a Unix group, which would give me read access to their HDFS files. So from the consumer side, we have a couple of different types of challenges here as well. So the access is largely controlled with membership in the Unix groups, as I mentioned. And then if we're considering the Hive CLI case, we have the problem of not being able to restrict or control access by a column or row level, or at that fine granularity. Finally, if you consider from the use case of the producer, when they create a table, until we have Hadoop file system ACLs implemented, you would really only be able to attach one particular group and give that one particular group read access to your table. So you're really only restricted at this point in time to one group for each table that you have in a particular database. And also keep in mind that the consumers of the data are running various jobs. They may be accessing the data through MapReduce jobs, PIG, Hive CLI jobs, ODBC, JDBC connections that allow BI tools to operate, or custom applications. So the last two slides that I have focus on what we did and what we would like to do with each of these two use cases. So for the use case of the fine-grained access control, it's largely the same story that they just had mentioned. We want to use the Hive Server 2 as the query execution engine and make everyone who needs that level of fine-grained access control go through the Hive Server 2. This allows us to provide that authorization level at the Hive Server 2 interface. We would also like to run the Hive Server 2 as a sort of a privileged super user, so that they would be able to access all of the underlying files that are stored in the Metastore. And there's sort of a reason behind this. I'm not going to go into it right now because the discussion can get a little bit long, but there you have it. Finally, we want to be able to define arbitrary access controls, again, using views. So we can, given a particular type of table, we can create an arbitrary number of views which restrict access to a particular set of columns or a combination of columns and rows or just rows. And about a year ago, using Sentry as sort of a preliminary tool to explore this space, we created a proof of concept that showed that these ideas would work well for us. So now that the authorization, the SQL-based authorization has been integrated into Hive 13, we're anxious to move to that technology and see what we can do with that. Okay, so